David Smith here with one more Flip Classroom math video in the rain. 3 tips before we start. First, you can speed up or slow down the playback if that helps you digest the content. Second, you can pause the video anytime and catch up with your notes. Lastly, you could turn on the captions and watch my words go by on the bottom of the screen. Today's lesson covers t-tests and what they mean and how we use them to analyze data. So let's get started. So the way t-tests are used is they are used to compare 2 sets of data. So what we do this is we do it by comparing their means or their averages. And so this allows us to do 2 things. One, we can compare 2 sets of data like population data or something like that and determine whether or not they're the same or whether any little differences can't be described by chance. We can do that. We can also compare one data set to a reference data set to see how different they are. So those are things we're going to be doing in a minute. I just want to review our HO and our HA, our hypothesis, the null, and our alternate hypothesis, something's different. So the HO is just there's no difference between the data sets. Any little differences can be explained by chance or by probability. So that's what our HO is, and our HA is that the difference between 2 data sets cannot be explained by chance, which makes sense. That's how we do that. So the test, when you run the test on your calculator, you're going to get 2 values. You're going to get a t statistic, and you're going to get a p value for significance level. All right, let's get a little notation heavy, talk about these averages, these parameters, and describe 2 types of t-tests. The 2 types are, we have a 2-tailed t-test and we have a 1-tailed t-test. You're just going to have to remember that these are a little bit different and be able to understand from the prompt which one you need to use. So check this out. We're going to talk about notation while describing the 2-tailed test. We have our HO and our HA. In a 2-tailed test, the HA is that the means from both data sets are equal. So X1 is data set 1, and we put a bar over it to symbolize we're talking about a mean. So over here with my thought bubble, bar over the X, that means mean, and what we say is X bar. So what we could do for this is say X1 bar and X2 bar. Or we could say X bar 1, X bar 2. I'm not gonna pick you apart for that. Okay, so mean from data set 1, mean from data set 2. They're equal. That is the null hypothesis, no difference. Now, the alternate hypothesis is that they're not equal. There is a significant statistical difference between the 2 populations under study. Okay, the 1-tailed test goes a little further, and it actually has you, the HO is the same as the HO for the 2-tailed test. But instead of saying that it's not equal, we're going to say that the mean for data set 1 is bigger than data set 2 or less than data set 2. And we're going to take a look at what that means in the context of doing a couple example problems. Okay, let's do a t-test on some data. So here's our scenario. We have a garden, and we're planting tulips on the right side and on the left side. And these are the heights of the tulips in centimeters, okay? So here's all the tulips that I measured on the right side, measured their heights, and then all the tulips on the left side. I'm sorry there's so much data here, but that's what we're going to do. So now check this out. One thing before we get started. These are not data points. These don't correspond to each other. There's not a point 21, 24. It's just a list of all the measurements I made. So we could just calculate the mean of that and the mean of that, and undoubtedly they're not going to be the same. However, we don't have a way of saying how different it needs to be for there's something to be going on between the 2 beds. Maybe one of them gets more sun, maybe one of them got a different fertilizer, we don't know. But we want to kind of see which one is growing the best. So we need to run a t-test so we can see if the difference in the average is significant or not. Okay, so I put the links for running the t-test down below. Basically, you just enter the values in a list or in a spreadsheet, L1, L2, or 2 columns in your Nspire spreadsheet, and then you follow the steps to run a t-test. And that's pretty much all you do need to pick the mu is not equal to mu. I think it's mu1 and mu2, because basically what we're trying to do is refute or prove this. If they're not equal, that means HO is true. No, that means that the HA is true and we can reject the HO. So if you're feeling bold, go ahead, pause the video, watch that other video, and then come back and do your t-test, and let's see what you get. All right, I gave you a significance level of 5%. That's a very common significance level, as you've seen as we worked our way through this chapter. So when I do this in my calculator, I get back, my t is minus 3.07, and my p-value is 0.00391. So now I want you to compare your p-value to your significance level and tell me, can you reject HO or not? Okay, so what I get is my p-value is less than my significance level, so it doesn't pass the significance level. So if you remember from previous lessons, that means we can reject HO, and we can say that there is a meaningful difference between these two groups of tulips. So then I just took a peek in my calculator to find out which average was higher, and it turned out that the left side was higher. So whatever it is that we're testing, increased sunlight or maybe better fertilizer, it turns out there is a statistical difference between the two beds of tulips. All right, let's do another example. In this situation, we have a chemistry test that was given to two different periods, and the teacher is wanting to know if there's a statistical difference between how the two groups perform. So like before, that teacher, she could calculate the average, the mean of this group and the mean of that group, but she wouldn't have a way to know if the difference was significant or not, which is what the t-test is going to tell us. So our hypothesis, the null, HO, is that x bar 1 and x bar 2 are equal, the means are equal, and HA, the alternative hypothesis, is that they're not equal. So now you have enough with your calculator to go ahead and fully do your calculations, bring back your t-value, your p-value, and then decide based on the p-value whether or not you can reject HO or not. Okay, when I do my calculation, I get a t-value of minus 0.235, and I get a p-value of 0.816. So when I compare my p to my significance level, I get much greater than 0.05. So that means in this case, we would accept HO, which is that they're equal. So regardless of what the means are for these two groups, it's not statistically significant. So we can't say for certain whether one period did better than the other period. Okay, one last example in this lesson. Here we have an oil company that claims to have a special fuel that increases the kilometers per mile traveled by a scooter. So they have this data. They tested this data on with the old fuel. They got 10 scooters. They recorded how far they could go on a liter of fuel, and then they got the new fuel and they put them in those 10 scooters and they did it again. HO, null hypothesis. There is no different. X bar 1 and X bar 2 are equal. HA is that X bar 2 is bigger, because that's the claim. They're saying that this new fuel does better. So you want to test that. So that's one of the steps in the calculator. You're able to select this or this. You want to make sure that you select, it's actually going to look like this. Okay, so you want to do that. You want to test that when you run it through your calculator. We have a significance level of 5% again. So I want you to pause the video, find your T and your P, and then decide if you can reject or accept HO. Okay, let's see how you did. So the t-value you get from this calculator is a minus 2.83. The p-value is 0.00561. And when we compare our p to our significance level, we get that the p-value is smaller than 0.05. It doesn't rise to meet the significance level. So that means that we can reject HO and we can accept HA, which means that the difference between the old and the new fuel in terms of kilometers per liter is significant. So then you could base an advertising campaign on this and make a claim that it increases your kilometers per liter by a certain amount. And you could get that amount by taking a look at the X bar stat for your old and for your new fuel. And you could use that to make your claim. Thanks for watching. Just before you go, make sure to write down any questions that you have so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.